Welcome back to the AI interview question series for developers. In previous video, we discussed structured output, JSON responses, function calling, and tools. Today, we are moving into a very important area for developers, Spring AI. We will discuss how a Java application communicates with an LLM, what Spring AI is, what chat client does, how prompts are sent, and how the response comes back to our application. Let's begin with question number 41. What is Spring AI? It is a Spring framework designed to help Java developers build applications using artificial intelligence. Instead of manually implementing all the communication logic with an AI provider, Spring AI provides abstractions and APIs that make it easier to work with AI models. For example, a Java application can use Spring AI to communicate with large language models, embedding models, vector databases, RAG pipelines, tools, and function calling. The important idea is that Spring AI brings AI capabilities into the familiar Spring Boot ecosystem. So, a Java developer who already understands Spring Boot can use similar concepts while building AI powered applications. Why use Spring AI instead of direct API calls? A Java application can directly call an AI provider's REST API using an HTTP client. But then the developer needs to handle many details manually. For example, creating HTTP request, managing authentication, creating request JSON, parsing response JSON, handling errors, managing model specific details. Now, Spring AI provides abstractions that simplify this process. Our application can work with Spring AI APIs, and Spring AI handles much of the communication with model provider. This makes the code cleaner and also makes it easier to switch between different AI model providers. The exact APIs may differ between providers, but our application can work with a common abstraction. What is Chat Client and Spring AI? Chat Client is one of the important APIs used in Spring AI to interact with chat based AI models. It provides a fluent API for creating prompts and sending them to a model. For example, string response equal to chatclient.prompt.user. In that, we write our query, explain dependency injection in Spring Boot, then .call.content. Let's understand the flow. First, we create a prompt, then we provide the user message. The call method sends the request to AI model. Finally, content retrieves the generated text response. This gives developers a simple way to communicate with an LLM. Let's understand the complete flow from Java to an LLM. Suppose a user sends a request from our browser. The request reaches our Spring Boot controller. The controller passes the request to a service. The service uses Spring AI's chat client. Chat client creates a request for the AI model. Spring AI communicates with the model provider over HTTP. The LLM processes the prompt and generates a response. The response comes back through Spring AI. The service receives it. And finally, the controller sends the response back to the client. So the complete flow is client to controller to service to Spring AI to AI model, then response back to the client. To use an AI model in a Spring Boot application, we generally need to configure the model provider and the required credentials. For example, the application may need an API key, the model name, the provider configuration, other model parameters. The API key should not be hard coded directly in Java source code. Instead, we should use configurations such as environment variables or secure configuration management. For example, API underscore key equal to your secret key. The application reads the configuration at runtime, then Spring AI uses the configured model connection to communicate with the AI provider. This is important from both a design and security perspective. In Spring AI, a prompt represents the input sent to the AI model. A prompt can contain different types of messages. For example, a system message defines the behavior of the AI. A user message contains the actual request. Additional context may also be included. For example, chatclient.prompt.system. In that argument, you are a Java expert. Dot user explain interfaces in Java .call .content. Here the system message defines the role that you are a Java expert. The user message defines the actual task, explain interfaces in Java. Spring AI helps us construct this interaction using Java APIs. How can a Java application get a structured response from an LLM? An AI model usually generates text, but many business applications need structured data. For example, suppose we want to extract customer details. Instead of receiving plain text, we may want a Java object. The flow can be user input to LLM to structured response, then a Java object. For example, class customer, and we have two variables in it, string name and string email. The AI response can be mapped to this object. This is useful in applications such as document processing, invoice extraction, resume analysis, customer support, or data classification. The important point is that AI response can become part of normal Java application processing. How do you build an AI REST API with Spring Boot? Let's look at a typical architecture. The client sends a request, post call, /chat. The request reaches the controller. The controller should generally handle the HTTP layer. It passes the user's message to the service. The service uses ChatClient to communicate with the LLM. The LLM generates the response. The service receives the AI response. The controller returns it to the client. For example, conceptually, a chat method with post mapping /chat and a request body string message returns chat service dot ask message. Then the service may contain the AI interaction. For example, the method ask in service layer will have a string message as argument and it will return chat line.prompt.user message.call content. This keeps the application layered. The controller handles HTTP, the service handles business logic, Spring AI handles communication with the AI model. This is a good architecture based interview question. Why should AI calls be kept outside the controller? We should generally avoid putting all AI logic directly inside the controller. The controller should primarily handle HTTP request, input validation, HTTP response. The service should handle business logic, prompt creation, AI interaction, response processing. For example, the flow will be controller to chat service to chat client to LLM. This separation makes the code easier to test and maintain. If later we change the prompt, add RAG and add function calling or change the AI provider, we can make those changes in the service layer without altering the API layer. Let's quickly revise today's questions. Spring AI helps developers build AI powered applications using Spring concepts. It provides abstractions that simplify communication with AI models. Chat Client provides a fluent API for creating prompts and calling chat models. The typical flow is controller, service, Spring AI, AI model, and response. AI model configuration includes credentials and model settings. Prompts can contain system instructions, user messages, and context. AI responses can be converted into structured Java objects, and a Spring Boot AI application can expose a REST API that communicates with an LLM through a service layer. Today we covered questions 41 to 48. We moved from general AI concepts into practical Java and Spring AI development. We discussed Spring AI, chat client, prompts, AI model configuration, structured responses, and the complete flow from a REST API to an LLM. In next video, we will focus on one of the most important topics for developers building AI applications, RAG with Java and Spring AI. We will discuss the complete RAG flow, document ingestion, embeddings, vector databases, similarity search, and how the final answer is generated. I will see you in the next video. Thank you for watching. Please subscribe for more videos like this.